Hello everyone. Here we are going to continue about the basic electronics operational amplifier, which belongs to module 3. In the module 3, the whole complete syllabus, let me tell you about the whole complete syllabus of the module 3. First of all, we are going to discuss about the introduction to operational amplifier. Next, op-amp input modes and op-amp parameters, CMRR, that is common mode rejection ratio, input offset voltage and current, input bias current, input and output impedance, sleeve rate, and so on. These are few parameters of an op-amp. Op-amp is the short form of operational amplifier. Finally, we are going to discuss about the applications of op-amp also, which is very interesting. And in the applications, we are going to see about the different types of inverting amplifier, non-inverting amplifier, adder, voltage follower, integrator, differentiator, and comparator. See, this full, whatever I have told you just now, compromises of whole module 3 syllabus, okay, according to the syllabus of the basic electronics subject code 18ELN14. Out of this whole session, out of the whole module of module 3, we are going to break up into small sessions so that it will be easier for you to understand and we can go in further details. So here, coming to the module 3 session number 1, in this first session we are going to see here the introduction to operational amplifier, and in the operational amplifier, which is shortly called as op-amp, how we are going to draw it and how we are going to see the internal IC integrated circuit chip and the symbol and the model of an op-amp. Knowing the basics of these operational amplifier working and the internal structure, slowly we'll be moving on to the block diagram of an op-amp, or it is also called as the op-amp architecture. After knowing the architecture of an op-amp, then we'll be discussing about the advantages and disadvantages of op-amps. Okay, finally I just given you some references where the material has been taken. You can just refer to, or any basic electronics textbook also will do, prescribed textbook preferably. Finally, based on this particular session, I have framed an 10 questions of objective type, that is called as test for their MCQ. This enables that how well you have understood the session 1 of module 3. Okay, now going into the introduction to the operational amplifier. Operational amplifier, as I told in short, it is called as op-amp, and it is a 8-pin IC where the IC in the sense integrated circuit, and the number for this integrated circuit is MUA741, and this integrated circuit is a monolithic integrated circuit which compromises a general purpose operational amplifier. Initially, it was invented or manufactured by Fairchild in semiconductors in the year 1963. Okay, what does this op-amp do here is, see, op-amp is fundamentally a voltage amplifying device designed to be used with external feedback components such as resistors and capacitors between its input and output terminals, where I already told you in the previous session about the passive devices with this resistors and capacitor also belong to this passive devices. Now, why do you require this op-amp? An operational amplifier is an integrated circuit that can amplify weak electrical signals. Okay, here weak electrical signal means it actually acts as an amplifier. For example, if at the input 1 volt peak to peak voltage is being given, then at the output I expect the voltage level to be higher than 1 volt peak to peak. This is the concept of amplification. So It is a circuit which can amplify weak electrical signals. Coming back to the circuit symbol and model of an op-amp, here the number 741 represents the integrated IC, here the integrated IC 741 which is related or represented in op-amp. So mu A is given by the manufacturer, that is that semiconductor manufacturer IC. So the whole IC number is mu A 741. Okay, now this mu A 741 IC represents an operational amplifier IC. I hope I am very clear here. Now, since the number 741, I told you, it indicates operational amplifier IC. Now, we will go slowly into the depth of what is here in the internal architecture, like how it has been represented. Internal architecture in the sense here, it is a 8-pin IC. 1, 2, 3, 4, 5, 6, 7, 8. So see here, observe here, the number starts from 1 to 4 on left side, next from top to bottom on the left side, and next 5 to 8 on the right side from bottom to top. So please note the numbering, how you are going to read the IC numbers. The pins, 8 pins of an operational IC represents each of its naming function for each pin. Say pin number 1 is offset null, pin number 2 is inverting input, that is also represented as V minus, pin number 3 is non-inverting input, V plus, pin number 4 is negative voltage, Vs minus, that is here, that is a supply voltage. Okay, that is also called as a supply voltage pin, that is negative supply voltage. Next, pin number 5 is offset null, pin number 6 is output, where you are going to take the final output from this IC. Pin number 7 is positive supply voltage, Vs plus, and pin number 8 is no connection, where this pin is not at all being used. Okay, so here, having known the internal structure of an IC, we should know how to represent with the help of a symbol. To represent the IC with the help of the symbol, here you can see that out of 8 pin, here we are using only 5 pins. Okay, what about the other pins? 5 pins in the sense, the supply voltage is pin number 7, pin number 4, that is Vs plus, Vs minus, I told you. Next, pin number 2, pin number 3, inverting input and non-inverting input respectively. Finally, the output. The leftover pins are pin number 1, offset null, pin number 5, offset null, and pin number 8, obviously which has no connection, or which we told you pin is not used. Okay, and here this is the circuit model where internally it has been represented. Okay, now you may ask me, what is the difference between this circuit model and this? See, the same thing it is, but this is with the help of pin representation. Whenever there is a notch or a dot, then you have to keep the IC upwards, place the IC upwards, and then start reading the pin numbers. Here in this is just a symbol. In the symbol we are seeing what is the internal architecture. Okay, now the supply voltages ranges from 8 to 18 volts plus or minus value, where pin number 4 is a negative voltage supply voltage, pin number 7 is positive supply voltage. Positive supply voltage is also called as plus VCC, pin number 7, and minus VEE, pin number 4, negative supply voltage. Sometimes it can be represented as minus VCC also, or VS minus also. Okay, now when we see the cross-sectional view of the symbol, whatever is there in this IC here, we can see that there are two resistors, one at the input and one at the output. Hence, this resistor R1 or RIN is used to calculate the input impedance. This resistor R0, which is connected to the output, is used to calculate the output impedance. Okay, and this is the current source, the diamond shape here, rhombus shape. Now, what do you mean by input and output is wherever I am going to give the supply voltage here between V1 and V2, that is inverting and non-inverting input, there I will tell it as the input voltages. Wherever I am going to take the output, that is V0, pin number 6, that is the output voltage. Okay, the differential amplifier. Now we are going to come back to the architecture point of view. In the architecture, what we are going to see is here what exactly and how the op-amp consists of which are the other blocks. Okay, so as I told you, it has two voltage level V1, V2, inverting and non-inverting, and the output pin number 6 as V0. In between, in the same circuit which we have seen here, what is happening here is it is represented as a block diagram with the input block first consists of the differential amplifier, followed by high gain amplifier, next connected to the buffer and level shifter, next connected to the driver. The differential amplifier here is which consists of two BJTs or two MOSFET. Why we have to consider BJT? BJT is bipolar junction transistor. Okay, or MOSFET means metal oxide semiconductor field effect transistor. This we have already seen in the previous module also. These two are used as an amplifier. As I told you, op-amp is used to amplify weak electrical signal. So, to amplify a weak electrical signal, we have to have a BJT or any amplifier, BJT or a MOSFET. Now, where you have to connect it is, you have to connect it to the input side. Now, when I give it to the input side, I have two inputs, inverting and non-inverting. So, what happens? The difference between those two signals, whatever the difference between these two signals will get amplified. Okay. Now, the differential amplifier is consists of two BJT or MOSFET amplifiers connected in opposition in the sense inverting and non-inverting, pin number 2 and pin number 3, so as to amplify the difference of two input signal. Obviously, it has very high input impedance and low output impedance because of the characteristics of an op-amp, which I will be telling you little bit later. Now, there is something called as a driver at the output. What does the driver do is, a driver is a power amplifier which increases the output voltage swing and keeps the voltage swing symmetrically with respect to the ground. Why? Because at the output we are going to get the amplified signal, whereas at the input we are going to give the weak electrical signal. Hence, at the driver side where we are going to retrieve the output, we are expecting a very high amplified signal. What is this second block consists of? Means high gain amplifier. Gain in the sense, it is a ratio between output by input. So, gain is equal to output by input. If I want to calculate the voltage gain, it is equal to output voltage divided by input voltage. If I want to calculate the current gain, then it is equal to the output current divided by input current. Why this gain is being calculated? To find the ratio between your output to input. Next, if there are any fluctuations or any disturbances due to internal or external components, for that we have something called as level shifter or the buffer. Now, what is this buffer? Is a temporary where the temporary storage where the waveforms will be stored and the noise will be removed, because if there are any added up noise is present in that. Okay. Now, to remove that or to eliminate the external noises or the internal noises, from the components of an op-amp, then you require a level shifter or a buffer. Okay, this represents very clearly the block diagrams of an internal architecture of an op-amp. Now, going back to the advantages, after knowing what is an op-amp, how many pin it is, what is the internal structure, cross-sectional view, next op-amp architecture, what is the gain or what is the advantages we are going to get. So here although an op-amp has a open loop amplifier, see it's a open loop amplifier with a level of gain here with unity. Now op-amps are able to harness the advantages to a very high gain by using a negative feedback. This feedback also I'll be telling you later on in this section. In this way we can have the gain levels controllable and distortion levels can be kept very low. Now having this in mind here, now what are the advantages? Means it is of low cost, small size, versatility, flexibility and dependability. Simple advantages of an op-amp is directly related to the gain. Now, is there only advantages? Why don't we talk about the disadvantages? See, though the op-amp is used widely in practicals or real-time applications, though there is many applications based on the op-amp. Say for example, as I told you, some inverter. In the introduction of overview of the syllabus I just told you, there are some limitations to the device. What exactly is the limitation is the input current is not exactly zero. The input offset current also is not exactly zero. The input impedance is not exactly infinite. There is a limited common mode voltage range. The output impedance isn't it exactly zero. Why? All these is because there is some sort of fluctuations in the practicals when we are using this in real-time applications. So then we tell it is a limitation. There are voltage gain limitations also, including the phase shifts. Phase shifts is, say when we go in for oscillators or something, that is also one of the applications of an op-amp. So here, having known this disadvantages, advantages, the cross-sectional view of an op-amp, what is an op-amp or operational amplifier, just wind up the session here and we'll go in for the MCQ questions. And these are some of the references which I have taken it. You can refer to any prescribed basic electronics textbook, standard textbook. Okay, it is very basic fundamentals. In this, determine the output from the following circuit is telling. Now these are some of the questions. Here you have to answer based on the topics which we have covered now. Okay, finally at the end after you, it should be a self-test where finally at the end you have given you the answers also. Okay, thank you everyone for your patience listening. Take care. Bye.